Dr. Chuck, the science schmuck.
Synchronize. Now, you may be wondering, what am I going to be doing this fine Saturday morning? It's like 50 degrees outside, birds are singing, the sun is out. Well, unfortunately, I can't be exposed to light, so I'm in the basement. What am I doing in the basement? This is a really long stick. Amber. What is it? Sap. Just like yours truly. Amber is sap, or more or less sap, not actually sap. Amber is a substance that came from ancient prehistoric trees that dropped out of the trees because trees bleed when they're stabbed by, prehistoric people? Troglodytes? I don't know. Damage. Trees become damaged, they drop sap on the ground, the sap fossilizes. Amber is a very interesting substance in that although being made of sap, it's very valuable. So that makes me think, is it possible to synthesize amber? And I know what you're thinking. No. And I think, no. But I think I can come close. So that's what the point of this video is. That's what I'm going to be trying to do today. It's something I've wanted to do for... It smells like a hand. That's something I've wanted to do for years and years and years, is try to synthesize my own gemstones. Amber has been of interest for the past year or so, but I haven't really thought of a good way to do it until my knowledge of chemistry increased due to chemicals. Yes, breathing the chemicals will increase your knowledge of chemistry. It doesn't actually. It makes it shrink. So what is the starting point? Well, unfortunately, the trees that originally produced amber don't exist anymore. They are extinct because they existed a gajillion years ago, and they just died out subsequently. However, fortunately to that unfortunately, I have 2 bicycles in a basement, and I can't ride them down here. Apart from that aside, this. What is this? I bought it on Amazon. It's gum rosin. Gum rosin. This is actually a pretty common substance. Now, what is gum rosin? Here is an example of a piece that I washed off because it's weirdly dusty, and I don't know why. As you can see, it's a crystalline, well, semi-crystalline solid. It's not sticky, it's hard as a rock. This is actually pretty close to what amber is, kind of. Rosin is a substance produced by pine trees, which original amber probably didn't come from pine trees, because pine trees are modern, if you think about it. They didn't exist a long time ago. There weren't pine trees like there are today, different species and all. Evolution occurring. This comes from Georgia. I believe they cut down trees and the trees make sap, and it's like, well, what are we going to do with this? You turn it into this. What is this used for? Well, it has a variety of purposes. It can be used as a glue. It can additionally be, I think you use it for instruments somehow? It does have a flavor, but a very weak flavor. It's like licking a warm rock. It's kind of the thing. That looks like a piece of quartz, right? But it actually feels very warm. Not exactly like plastic. And a little bit more like glass, but it's not sharp, and it's very light, which already makes it an interesting substance. This is probably something I will keep a few pieces and run them through the rest of the process as is, because I think you could actually make gemstones out of this. Like really dry, hard rosin. Remember, rosin, not resin. It starts out as resin, turns into rosin. You could probably speak correctly into your microphone. Regardless, so the level of chemistry, it smells weird down here. The level of chemistry I need to do is that I want to convert this into something more amber-like, which is why I got all these chemicals. The first thing necessary to doing this sort of chemistry is to understand chemistry. And to do that, I drew a picture. Abiotic acid. So it looks like that. And you will notice that's a carboxylic acid. See? Acid. Which, okay, my hypothesis was initially, hey, a carboxylic acid. I can bind that to things, right? For example, lysine. Lysine is an amino acid that has 2 amino groups. You could form an amino bond. Probably. Problem is that's a dehydration reaction. It would require this to be in water. And look at the size of those organic groups. That's not going to dissolve. This doesn't dissolve. You could put that in water. It's not going to change. Maybe. Lysine is an ingredient I have here. In this form. Of mucus. although it looks kind of gross, that's powdered milk. Powdered milk is made of casein, which contains a lot of lysine in a polymeric polymer. Globular. I mean, it's not a long polymer, maybe it's little, but it's there. The other option I have, in actuality, the chemical way that amber forms has nothing to do with the carboxylic acid linking. It polymerizes based on breaking open this resonance structure of double bonds here. So that's something I don't really know how to do without like really fancy catalysts. And heat. Oh no, puberty's hitting my voice. I can't talk today. The other option is actually this. Look at that cool triester. That is something that occurred to me that was, a historical fact. It didn't literally occur to me. I didn't synthesize this, but I realized it. Linoleum. This sounds like an aside, but it isn't. What is linoleum? The answer is you don't know, and that's something I didn't know. Linoleum is actually this. What is this? I don't know. The side that has a label is facing you. Boiled linseed oil. The oil of boiled linseeds. Not actually. A little bit of history. This is also an organic compound just like this. Why do I have it on my desk? Because it's actually relatively cheap. Walmart has a solvent aisle. So you can actually go to Walmart and like any solvent you want, it's all here. Boiled linseed oil is exactly that. It's a triester with, which is a glycerol basically, but it's estered onto these really big long carboxylic acid chains. When that is exposed to oxygen, it's what's called a drying oil, and this dries. So why do I say linoleum? Because that's what linoleum is. It's this. Original linoleum was manufactured in the 1800s by combining cloth, cork fiber, and sawdust with this, pressing it, and allowing it to harden. It hardens by forming polymerization, which creates the linoleum. It's very durable, but it's also organic and potentially decomposable. This actually is made of linseeds, which grow on a lind tree, which is populated by lindworms. Not really. It comes from flax. Flax is a fibrous little flower that ancient people used to use to make clothing. We don't use it much anymore, except for this. Why is it boiled? Well, that's a weird thing. According to what I saw, it's not actually boiled. Boiled means they put chemicals in it that accelerate the hardening, which is usually lead acetate if you're prior to 1830. These days, I think it's cobalt. So, it's a good idea not to drink that, but in the interest of understanding what this is and why I had to be 18, I'm 42 now, so happy birthday to me. It's important to note that you shouldn't huff paint or solvents, but it's important to know what they smell like so that you know if there's a leak. This doesn't really have a smell. Very slight smell like paint. Not overwhelming. It's not like you just huff xylene or acetone. It's like, oh, somebody's been painting a wall. Like when you paint with water-based paint, normal house paint, you can see the wall. I didn't paint this. This was painted in the 30s by whoever built it. Actually, this house was actually originally 90 feet that way, and they pulled it in the 30s onto this foundation. So I wasn't there. I'm only 42. The 30s was like 20 years ago. I was like a kid. But the point is, part of my formulation requires combining this in the form of rosin with a polymerizing oil, such as this, as well as secondary ingredients. And what secondary ingredients do I have? Well, some of these are for different projects. So, for example, we have Depolith. That's not going in right now. Some carbon. Where did I get this carbon? Remember me making all that lye? Well, I almost dropped my carbon. All that lye, the wood ash has carbon in it in the form of charcoal. I let the charcoal float to the top, rinsed it off, dried it out. Not in the microwave, it explodes violently. And mortar and pestled it until it's a nice black powder. If you recall, I did use this for makeup. It doesn't work well because I look terrible in makeup. I've also got the stuff from remember, I brought back the copper carbonate. It's now nice and mortared and pestled down to a nice green substance. Also, my unknown blue substance from the same experiment. with the idea of producing dye. So the first thing to be first is, one, I need a drying rack. I don't have a drying rack, but I've got aluminum foil. Alright, I got the aluminum foil. So now I've got my science hot plate here, and I'm going to want to turn this up to a low temperature. Do note that these materials are highly flammable. I am inflammable, so I'm hoping it doesn't try to kill me. I'll then take a lump or two of this material. Oh, it's getting everywhere. I dropped it under the table. Hold on a second. Ugh, I just stuck my face near something real smelly. So I'm going to take that, drop it into my crucible here, which is actually a can that I cut. Do be careful if you're cutting cans. They are very pointy on the edges. You're going to want your sea peepers so that you lose your sea peepers. A pair of pliers is useful. Notice I cut the can like this because I'm lazy. It's actually very hard to cut a can like this unless you have a lot of time. Not with scissors. Don't use scissors. You'll die. Use metal shears. Hold on a second. Metal shears. Use these, not scissors. They're big scissors designed for cutting sheet metal. That's how you cut cans, not scissors. Why am I saying all of this? Because I'm starting to get excited. I don't know what's going on. Yes, as apparent here, the rosin is melting down into a liquid. And that's exactly what we want, that liquid. However, I think it's too hot, and it probably shouldn't be smoking. Problem. That's a chemical reaction that we don't want. The can is on fire and smoking. This is going to set off the smoke detectors. First off, I'm just going to pour what's left out and see what we get. I can always reharden it and reuse it later. So, what the problem is that may be observable to you, and that you probably already knew and I didn't, the can is lined with a substance. That substance, I don't know the name of. However, that substance burned. The smoke was not the rosin burning. The rosin, as you can see, is fine. It actually smells very potent. Not bad. It's like sawdust. Like when you cut wood, like you cut a bunch of pine with a chop saw. The problem is not the rosin burning, but that the rosin corroded through the liner of the can. So I need to figure out a way to get the liner out. Fortunately, I know exactly how to do that. This is a little bit of a sneak into production that you probably don't need to know, but I'm actually filming many videos at the same time at any given time. The banana upstairs, remember that? It's cooking at 500 degrees. I can put this in there and burn off all of this material on the can and leave it nice and metal. By the time I get back, this will have hardened into nice firm rosin that I can then put back. Additionally, I'm going to need to fold the aluminum foil better. This is not nearly as viscous as I had hoped. As you can see, it spread out too much. So, I'll be back once I've fixed that, and these mistakes are how we learn. Just remember to be able to put out a fire and wear your goggles. So, this is a really long stick. I processed the can. I don't know if that's going to make it into the video previously. Oh, it's too hot. So, all of that stuff was originally red because this was tomato puree. It tastes like the inside of a can, but it's cheaper than tomato sauce. I don't know if that's good. I'm going to add some more. Throw in some of this rosin. Melt that down quickly. Now here's the fun part. This is ridiculously flammable. So I don't know what's going to happen when I apply some of this. Do I have a cup? A small quantity quantity of linseed oil and apply that directly to the rosin. That's what this stick is for. To subsequently mix the resulting solution so that the highly polymerizable, hardening linseed oil can combine with the rosin. The resulting substance should be harder than ordinary rosin once fully polymerized. I take one of these aluminum crucibles. The idea of these being that once it's actually hardened, I can just break it apart, as these were. They were probably a plate. Use pliers, because it's probably hot. And pour. The resulting material is a very dark color, possibly due to contamination of the container, also possibly due to contamination of the combination of linseed oil and rosin. Carbonization, well, we'll see if it works. I'm going to turn this back on slightly. Remember, as slight as possible. And now, I don't know what formulation is actually going to be necessary to produce a substance that is structurally similar to amber. So, I need to try a few. First, I'm going to throw in some of this rosin and melt it down. My linseed oil is hardening somewhat quickly, but that's expected. It basically is going rancid. So it hardens on contact with air, so you want to kind of keep that closed and keep that refrigerated when not in use. Yeah, it's weird, but I keep all of my solvents cold. I find it helps preserve them over time. Also, a thing to note about linseed oil is, while this is melting, an interesting bit of, I guess, trivia, linseed oil, as it hardens, is a highly exothermic reaction. It also is highly flammable. So if you get this on a rag, for example, and then just leave it somewhere, or a paper towel, the amount of heat as it dries is so great that it can ignite that paper or cloth and itself on fire. Therefore, you have to be very, very careful with this stuff. And don't leave it alone. Use a long stick. Now, we want to avoid fire if at all possible, because this solution is made of basically fuel. I mean, this will burn horribly if it catches on fire. It would be a good idea to have a fire extinguisher near you. I don't have one because I'm stupid. Okay, this next batch, the ingredient I'm going to add is milkies, which is powdered skim milk. The idea being, as stated before, that this can lead to a partial polymerization reaction with the carboxylic acids present. Probably if there's water, but there isn't water, so about that much seems like a good amount. It's fizzing and foaming. I don't know if that's good or bad. The resulting solution is basically pine milk. It does not look good. But I'm going to keep stirring from a distance. Ugh. See, I think part of the problem here is that this stuff actually really can't survive high temperatures very well. Milk, you put it through an autoclave, it just turns brown. Believe me, I put milk in an autoclave. So this substance here is actually a few hundred degrees because it's basically oil. It's frying. So the resulting substance is very unpleasant looking and brown, and it's burning. The problem, yes, that is a bit of a failure in that the milk burned and produced carbon deposits. So I will allow it to continue to harden and do what it may do, just to see if there's any use left in it. But in case there isn't, I need to go clean this out before we move on to the next part of the experiment, which will involve using things that won't burn in the form of inorganic chemicals. Well, as it turns out, whatever I just made was very unpleasant. It was so sticky and so gross I could not get it out of the can, except residual pieces. So I have replaced the can with a different one. At the same time, while I was doing that, these have hardened, not enough to take out of the mold, but the milk one is sticky. The other one is also sticky. This time, what I'm going to do is, instead of using milk, because that doesn't work, it thermally destabilizes. I'm instead going to use some of this. Remember we made all that? Well, here's a use for it. This, I'm having a hard time because that stinks so bad. It's not as bad as bone water. It's not even a tenth of bone water. But this stuff produces a smell like, cutting lumber. Like you're burning wood. It smells kind of nice. When you combine it with burnt milk, now do you know what burnt milk smells like? Fish. I don't know why. Like, there are not fish in cows. Cows do not fish. They do not produce fish. Fish do not come out of the udders. Fish do not drink the milk. That I know of. I hope not. The point is, I don't know why it smells like fish, but it's really gross when it's combined with the smell of these things. Regardless, the next stage is copper carbonate, which does decompose. That's the problem I had last time. But it does it at like 400 degrees. So I don't think this is going to get that hot. Hopefully it won't. I don't know why my throat kind of hurts. Oh well. It's very sudden. So I'm going to drop in some of the rosin. And then heat as gently as possible. Gentle. The click means it's working. I need to breathe, but it smells bad. And it's annoying. And I'm whining, but it doesn't really matter. It probably helps me breathe less radon. So I need to wait for that to milk in this milk. Am I even going to be able to... Well, milk doesn't actually usually taste like fish, so it shouldn't be a problem. Idea would be that by combining it with this copper carbonate, I can turn it green. However, it's not a very green color. Yeah, it's a lot stickier than I had hoped. And I probably shouldn't have got it covered all in fingerprints, but that's essentially what it looks like. The linseed oil probably isn't the best idea at this juncture. It needs to harden. Like, that needs to go for a few days before it's hard enough to do anything with. Then I will shatter it and hopefully polish it. So the next version will omit the linseed oil and instead just add the carbonate to hopefully act as a binder, creating a semi-mineral substance. That won't technically be amber, though, because it won't be very highly polymerized. But hopefully it'll be somewhat close. That's what it looks like. It's all gooey and sticky. Now it's stuck on the end of my stick. So I'm just going to swirl that around until it's nice and melty. And it falls off my stick. I could just wave the stick around, but this stuff is like 200 degrees and super sticky. If you've ever worked with molten sugar for candy making, you know how they say it burns like napalm? This is the same stuff. Actually, I think this is closer to what you would actually use in napalm. Napalm isn't this exactly. Napalm is sticky gasoline, more or less. I believe it was made at some, it's different recipes, but I believe it's made by dissolving polystyrene in gasoline till it gets thick. So, let's hope that this doesn't combust or explode in any way. It has a very fresh, clean smell. Not like detergent, but like somebody just cleaned the jar. Oh well. Let's add some of that. Hopefully it doesn't produce too much of a chemical reaction. We are adding an acid to a base here. This is basic copper carbonate, which is, it has a hydroxide group attached to it. And that, as I already mentioned, is a carboxylic acid. So that means that we are combining an acid and a base, which may produce a little bit of a reaction. The thing is, acids and bases at this level don't necessarily do anything. kind of a weird thing, needs more of this, kind of a weird thing that you don't necessarily think about is that acids and bases are not acids and bases functionally until they're dissolved in water. The hydrogen, like an acid is a hydrogen needs to leave an organ. This is too boring, you don't care, but the hydrogen will not leave and become active unless there is water to stabilize it. In other words, you could, well, I was going to say you could stick your hand in like hydrogen chloride, which is hydrochloric acid, but you are made of water. It will react with you. Strong acids do weird stuff. But this is a very weak acid. I mean, that's something that, you can see it's turning green because I added green to it. People think acid and they immediately think something that you dunk superheroes into. That's not really the case. And I'm sure you realize this, but acid is a very general term for a very large number of substances that basically release hydrogen in solution. Weak acids, like what this is, don't dissolve and don't really release very much hydrogen at all, and therefore have very little effect on the pH. Strong acids do release a lot of hydrogen, like hydrochloric acid, for example, releases a lot of hydrogen. Which, the idea of weak, strong acids isn't really, it's not the best way to go about it, because there are some acids that will dissolve you very quick that are weak acids, like hydrofluoric acid is considered a weak acid. But if you get hydrofluoric acid on you, you're going to burn. I mean, even glacial acetic acid, that's kind of a weak acid. Phosphoric acid, weak acid, they'll still dissolve right through you. I just heard groaning. That's a new sound. We are getting a bit of smoke, which is not good. I need to cut down the temperature before this boils itself into oblivion. It's probably more like organic steam. Now, if this stuff does not actually work, if it's not too tacky, it has the advantage of potentially serving as a, let me cool that down a second. I'd say I have a bucket of water next to me, but that's not water. So, yes. It's not currently heating, so I have a little bit of time to explain this. This substance, ideally, can be used as a gemstone substitute. So, polish it up, make jewelry out of it. That's the idea. There's a chance that won't work. If that doesn't work, then what I can actually do is use this to cast parts, like knife handles or knife blades. I don't think I can make a blade out of amber. That wouldn't be very sharp. But I can cast the blades, not the blades, the blade! No, I can cast the handle, I can cast basic small plastic parts out of this. Potentially in several colors. I needed one more of these for one more test that I want to do. Well, a few more tests. I'm having fun. Are you having fun? You're probably kind of smelly. You're probably not having the greatest time right now, but I'm having more fun than I have had all week, so I'm going to keep going and keep going until I reach a failure point.